Okay. Sure, please do. Come on, grab a seat. You know, no reason to stand. There we go. So this is going to be a panel discussion, not a. We haven't rehearsed. We talked about some of the questions ahead of time, so they know what was coming. But I got a few zingers in my back pocket, so. But so welcome everybody to the RIST discussion for IBC 2019. I think what we should do is I know you've all introduced yourselves before talking earlier, but why don't we just pass the microphone down? Everybody just, introduce who you are, your company affiliation, and while you're at it, why don't you tell us why you're here? What is it that you're most excited about with RIST?
Wow, where to start? So David Griggs probably just heard me. So I'm a senior product manager for AWS Elemental, and I'm responsible for Media Connect, which is our transport stream over IP service. Why am I excited about RIST? I'm excited about the opportunity that it brings to not only us, but just about everybody on this stage, and hopefully some of you there as well, to really work together in new and innovative ways. And I think that's, to me, what really gets me excited when I start to think about where we can take this.
Hi, I'm Ciro Noronha, Director of Technology Compression Systems for Cobalt Digital. In that position, I look over after all the compression stuff, and that's really RIST is really a natural extension of what I do, because once we make the bits, we have to deliver them. So it's very natural that I get involved with this, and with this group of people, we don't always agree, but we all have very relevant experience. And that's one thing I really appreciate in this group, that everybody is happy to share what they know and what the experience is, and that makes for a much better protocol. They have field experience. There's like many years of experience over here, and everybody's sharing because we want it to be the best possible as a result of that. So we don't hide anything. We just go and do the best we can.
And duke it out, almost.
That doesn't mean that's easy.
No, not at all.
On the opposite, because we all have very strong opinions. But see, we're doing it already.
Yeah, you guys, we've been doing a good job, I think. But
all right.
Okay.
Hi, I'm Sergio Ammirata, CTO of DVO, and I'm excited about the final product. I'm excited that we were able to grab the best of everybody's protocol and put it into RIST, and I feel blessed to be part of this. A few years from now, 5 years from now, when this is all that left, we'll all look back and say, wow, we were part of that. We were part of the creation of a protocol that became the standard on this type of transmission.
So I'm Alexander Sandstrom, product management at NetInsight. And I think the reason I am here and we are part of the whole RIST movement is that we've been working with internet media transport for many years, which many others have as well. It's been growing in importance, and I think it's just a natural next step to make sure that it's interoperable, that we're now collaborating, making sure people can build bigger and better solutions that involve multiple different players in the industry. So I think it's just a natural next step, and it's an important next step to take media over internet and media over public networks to the next step.
Hi, I'm Adi Rozenberg. I'm the CTO and co-founder of VideoFlow. Why am I involved with RIST? For me, RIST is the next ASI. And in my position on those Wednesday calls that we have every other week, or every week actually, is sharing my experience with the group, sharing what VideoFlow developed and sharing that with the group, guiding, teaching, talking, learning, because we, as my peers said, we are learning things and sharing experience to find a better product that will move this industry forward. As I'm involved with installation, I see ignorance, but I also see a lot of hope, with the hope that there will be one protocol, or there might be even several, but one that it will be interoperable. So one vendor A will talk with vendor B and C, and won't have to basically each time invent something new. And that is something that I'm all about.
I'm Uri Avni, CTO and co-founder of Zixi. I share the excitement of my peers here about interoperability, ability to work in what used to be a very fragmented world of reliable delivery and unifying all of our forces and all of our products to be able to talk with each other and help the industry. Great,
thank you. So we'll make this a toss-up question, 5 points. No. There are a lot of, and we can definitely have multiple answers on this. There are a lot of ARQ-based products on the market today, okay? And there's other technology consortiums and groups that use, ARQ technology. So what is it that makes RIST better in your mind?
I'll start by saying that RIST it looks like a natural evolvement of RTP, of how people are used to deliver video over IP. So it is cross-operable with decoders and encoders that can talk RTP but cannot talk ARQ. It will still gracefully work with them in a way that is not possible with some of the other alternatives, including our own alternative. It can also work with multicast, and can also work with video gateways and routers and analyzers that exist out there. It was, for example, developing at least the simple profile of RIST. Every equipment out there understands RTP. RTCP has been around for many years, 20 years or so. We didn't invent here any new protocol. We took existing RFCs and put them together in a way that we all agreed on, in a way that is a natural evolvement for video over IP as it exists today.
Anybody else?
Well, ARQ is something that's been around since the 60s. I tried to find out who invented it. I wasn't successful. I lost track in 1960 in packet radio. So it's not that we're inventing something new and cool and very, very clever. It's been there already. The cool thing is we're working together and we're making it interoperable. That's the cool thing.
Yeah, definitely second that, and your point too. I think that's really what's cool for me, is that this isn't one vendor's solution. This is something that we've come together on across multiple organizations, and I think when you have investment across multiple organizations, you end up with a better product and something that will service everyone and not just individual corporations.
Anybody else? That's fine. Okay, so right now the state of the art in RIST as far as a published specification is called the simple profile. Okay, so what is the benefit today for a user to go with simple profile versus some of the other technologies that are currently available? What can a user expect to get today that they can't get any other way?
Besides the protection, simple profile has one key thing, which is multi-link support in a vendor-independent way. So you can get bonding, where you can split your stream over multiple links and then gets it together on the other side, and you can get seamless switching, completely compatible with 2022-7. So those are two very important things. Sometimes they are overlooked. That's already in simple profile. They've been in RIST from day one and are available today from more than one vendor.
It automatically brings compatibility to protocols that used to be disjointed, like the FEC support that's built in, the bonding. Now with one simple workflow, suddenly all these specs collapse into one. RIST now becomes a standard for FEC transmissions, for bonding, there's several 22-X specs that automatically collapse, and we can call them RIST now.
So I did want to, I hope everybody noticed that we have a pretty much of an international panel here. I mean, thank goodness we all speak English, but it's a very eclectic group of experts from a lot of different backgrounds and PhDs and things like that. So it's an awful lot of fun to work with. So leveraging that, where do you see this being applied outside of broadcast television? Where do you see places that really could benefit from this technology that maybe we aren't thinking about a lot today?
Okay, with the introduction of the main profile and the tunneling, the ability to move non-transport stream data, but rather any type of data, that opens the road for new applications, meaning that now we can do bonding for TCP flows. You don't need a special TCP stack to do bonding to deliver TCP. That is already in the main profile, and hopefully it will be enhanced further in the enhanced profile by introduction of ARQ to that. Suddenly, we will be able to move maybe RTMP through the RIST tunnel without any transport stream, provide ARQ to an RTMP. That will bring new life to RTMP flows by the use of RIST. I fondly said that at last NAB. The RIST tunnel can be used to to provide bonding for SRT, which is missing right now. The RIST tunnel can deliver SRT, provide ARQ in the future that will solve some of the problems and the weaknesses of SRT to make it a better solution. The ability to play with the null packet will provide new applications and capabilities to provide diverse service that are not so visible today, but can be apparent when it will come to be available in products.
So does that open up some new markets that you're thinking about? I mean,
Yeah.
outside of broadcast quality video.
We can talk about autonomous cars. We can talk about low latency video delivery. We can talk about non-compressed. We can see the bonding, the merger of ST2110 with RIST by way of one delivery. This is something that the 2110 group is working on. They can now take the RIST and use that. We can talk about 5G, the use of RIST for 5G in their applications. So those are new opportunities, new exciting capabilities that can be added. We can talk about joining ATC 3.0 or STLTP, things like that are not common right now, but they will be very apparent in 2 to 3 years to everybody by the way of using the RIST main profile and maybe some enhanced capabilities.
So anybody else want to comment about markets?
There's a very big unexploited market, which is gaming and remote production. The average user on his PC, Windows, using OBS software or some other software to film himself as he plays. And it's being broadcasted typically through some sort of RTMP push. I see the minute that this gets embraced and they add RIST to those applications, they're going to skyrocket.
Totally agree. We see esports as being on the cusp of something very, very big. It's a whole new, well, the paradigm isn't that different, but the content is, and the audience almost definitely is. And I think that we're on, my perspective, and certainly the perspective of my colleagues, are that, esports and gaming, and not necessarily gambling, but just this new kind of sports is really something we're going to see explode in the next few years. I think UGC, I think one of the great things about RIST is it truly democratizes that's a very AWS word, but it truly does democratize the access to some very interesting solutions across the board to just about anyone. And I think that is going to lead to some really interesting non-broadcast and potentially non-video, but I think even in the video space, non-broadcast solutions and exciting new ways for us to watch and consume content.
Well, great. So, Adi, you mentioned the main profile. Let's get some opinions about where we are today with simple profile. What does main profile do, and when do you think main profile is going to be ready to go? Who wants to comment about that? No. I was just building on that. Anybody. All these questions are for anyone.
So I think just like we've spent the day talking about a bunch of different use cases that are enabled by main profile, and I think there's many exciting ones. I think encryption is the obvious, I'd say, priority one feature to get in there, right? Because that really opens up for using infrastructure that you wouldn't want to use the simple profile over. But I think also as we had from our side a talk about like higher end workflows, I think you were onto it, Ciro, we had bonding in the first release of RIST, and that's really, we talked about non-broadcast applications, but I think one of the key strengths of RIST is that it's developed first and foremost as a really high-end protocol for high-end workflows and with very strong requirements on quality, right? And this is where we, I think, see that the extension of more higher bandwidth services with RIST main profile is a key one as well, to kind of climb the value chain from just MPEG-4 and HEVC encoded video to lossless and possibly even beyond.
Another exciting feature of the RIST main profile is the ability to use pull mode versus push mode, meaning a client-initiated session versus a sender-initiated session, which opens up the possibility of doing large-scale distributions with RIST. Otherwise, you would need to open a firewall for each and every receiver out there, and it's less scalable than having those receivers sit behind a firewall, behind a NAT, and pull the stream down. And what Adi mentioned earlier, the ability to multiplex non-video traffic inside of a tunnel for control or for other use cases.
The addition of multicast support, bidirectional traffic, multiplex traffic inside a tunnel allows you now send, receive. You're not limited on a unidirectional method. You can send forward error correction, you can send multicast, you can send unicast through the tunnel. You can do duplication to the tunnel and do bonding for the tunnels. Ciro touched based on that in his presentation. There's also now another exciting feature, the PSK, which is a form of encryption, but that opens the door for point-to-multipoint distribution where you don't have to register ahead of time to receive the content. You can just come in, have a shared key, connect, and you have a secure connection. And we made very sure that it is with rotating keys and a very strong encryption there. So now that's a viable situation to replace satellite distribution. Maybe not to 1 to million, but maybe to affiliates, or 1 to 200 or 300. By the way of that RIST and with PSK, now you have a viable solution to do that easy. Now, because I'm a vendor and Uri is a vendor and other vendors, RIST becomes a solution that sometimes it's better than the solution that we have in-house proprietary solutions. RIST, because we joint effort, here we have 5 vendors, but there are other vendors working with us. We have a solution which is better than the solution that is proprietary in its own company.
And I want to stress something about the non-video data, the in-band control. I keep coming back to that because it is an actual requirement that's coming from the field. We had a big discussion. Some people didn't want to put it in the standard, but it is necessary. I've seen actual RFPs where that's written in because everybody wants to do more with less. So they're going to send a van there, and there is a 19-year-old, nothing against 19-year-olds, but with a driver's license and not much more. And if there's something that needs to be adjusted in the equipment, you want to have the technician at the head end be able to dial in and write the same connection back. Yeah, you can do that with VPN. Yeah, there's other solutions, but it's all in an integrated package.
Very good, very good. So with the main profile, let's talk about time frame. You know, when's it going to happen? When's the spec going to be released? And I know that we're predicting the future here, and you know, we've been wrong before, but you know, when is it going to be released, and when are we going to see products that do it? I mean, obviously we've got some neat prototypes here, but you know, what do you think? What's the schedule?
That's a marketing question. Maybe we get Alex to answer that one. Any day now. Let me comment a little bit, then I give it to you. So main profile is actually obviously a bit more complicated than simple profile. So, what I'm going to say here is my view, my personal view, is that, yeah, we have an interrupt, we have something running in YouTube, we're showing both streams in the clear and encrypted, that's working. But there's a lot more that we need to test. And I personally would be uncomfortable releasing the specification until we have all more than one few implemented and tested more of it. So crystal ball, I don't know, a few more months, and then it goes to the VSF board. We kind of agreed in the AG that we have a viable draft, but I personally would like to see a bit more field experience.
Yeah, I can just add to that you should look at it this way, right? The main profile is an addition to, is an add-on to adding functions to a simple profile, which is today available in commercial products. So even though, and there are now multiple vendors that do main profile interops that we've seen, and there's a live demo up and running, and those are not, that's not hacks. Like those are, yeah, you could call them prototypes, but they're built on commercially available products. So I think that the difference between what we have now and a productized, commercially available product is not as big as it was when we did the simple profile, because then many started from scratch, right? And it was truly prototypes that came out in the beginning. Now we're building on commercially available products that are robust and on the market. So I think when the draft is out, we're going to have commercial products pretty much at the same time. That's my crystal ball view, at least.
My view is somewhat different. With all
That's a surprise.
Yeah. With the introduction of a tunnel, we have a viable commercial product. The tunnel, without even encryption, is a viable product that you can move, push data through as a unicast, multicast. Yes, it does lack encryption, but you can also be well assured that that encryption will come, because maybe you trust us, maybe you don't, but at least the minimum DTLS, which is a minimum, DTLS is a minimum, right? Will be supported by everybody as mandatory. Now, just for you to understand, as vendors, manufacturers, how hard it is to add a tunnel, it is 3 lines of code, right? 3 lines of code to add to a simple profile, and you have a tunnel running. That's how hard it is. That code, you can reach anybody, or you can go to the RIST Forum members. He will show you that 3 lines of code, but probably there will be solutions out there before even the standard or the document is finally sealed. So you can go to the market. You can start do that. Also, there will be products, I'm pretty sure that Zigbee are doing something like that, that will be a basic gateway. It will basically allow to connect multiple simple RIST devices through a gateway. The gateway will do the smart things. It will do the encryption. You don't have to invest money into that. So you can go right now to the market. I'm talking about weeks, not months, but weeks, for products that I don't know when Zigbee will launch them, but I know when VideoFlow will do that you will have a first commercial usable main profile solution that you can trust. It will be viable and working.
Okay, so let me ask this. If, and by the way, I want to make sure everybody understands here in the audience, if you have a question, I want to hear from you. You'll get priority over anything I'm going to ask. So just let me know and we'll bring the mic to you. Okay.
So this is a question for pretty much everyone here, I think. I think one thing that, truth be told, commercial solutions and even SRT has a good advantage of right now is the fact that it's one implementation. It's very clear what the terminology is. It's 6EU push pull, SRDS caller listener. What are you thinking in terms of terminology and to make it really simple for actually configuring devices between different vendors as well?
It's a great question, and it is a challenge. I don't have a good answer right now. There are some complex technical details when, especially for the RIST main profile, when establishing a connection. This is one thing that we ran into when doing the interoperability test. There's external addresses, external ports, virtual interfaces. We would need to come up with better terminology as a group to be able to communicate it out in a clear way and to put consistent solutions, UI, fields, names, and so on out there that users will be able to operate easily. So I don't have a good answer, but it's a good point.
To answer you, basically we made the main profile simple to use. There's the complex mode that you can go the full Monty, auto configuration, files being delivered both ways, connect, disconnect. We even didn't touch base on all those capabilities. But as a simple, basic, the heart of the protocol is that you basically decide, I'm a server or I'm a client. This is my tunnel. This is my IP address. Well, that is where I need to connect. And this is my simple profile. Done. And believe me, because right now we integrated SRT, it's much more easier to understand RIST, debug RIST, put it on a Wireshark with the help of Zigzee that contributed the dissector. It's very easy to debug, not compared to the competition.
RIST main profile gives you a number of tools that go from simple to complex and gives the vendors the ability to make very cool, very smart products that are simple to use and yet provide very complex functionality if you desire to do so. So basic tunnel, a whole bunch of streams, I can hide most of it from you and it's still going to work. Very simple interface. You don't have to know very much. Or I can make my receiver on the other side auto-detect everything. Just show you, here's what's coming in the tunnel. Just tell me where you want it to go. Automatic. So you can be as smart as you want. You have the tools to make a product that's going to look great for your customers, that has all kinds of bells and whistles and easy to use.
Sorry about that. So I think my point is not necessarily that you need to make it smart. My point is that you all need to make it smart the same way for this actually to go full adoption, right?
And that's it's a good point, and we'll take it to heart.
I think that at the end of the day, you will see a range of devices that implement multiple layers, from the simplest ones that only support one argument, like a VLC player, for example, where you have to put a URL and you're done, to the more sophisticated gateways that do all sorts of IP routing.
Okay. So that brings up an interesting point. So, we have products on the market today that are based on simple profile. The release of main profile is imminent. Okay. What is it going to take for users to upgrade or to convert or things like that? Is it going to be download a new rev of firmware and they're off to the races, or is it going to be have to re-architect their systems. Tell me what you envision as the upgrade. And I think Dave wants the microphone.
Well, we're quite lucky in the sense that everything is software for us, so it does make it a little bit easier. Yeah, I mean, so I think that's some area actually we have some work to do in, from being brutally honest. Yes, it all runs in the cloud, and yes, we have control over all of that, but to do that in a way that's not interruptive, that's not destructive to, for example, in general terms, not just from simple to main profile, but any software upgrade in our platform, we want to try and find new ways to do that. But the intention would be that it's seamless. We might, at a minimum, just require you to restart essentially a Media Connect flow to do that.
I think the simple answer is yes to the way you phrased the question. Software upgrade is going to add the function to existing platforms, and I think that's true for most.
So we don't need any. Well, the anticipation is that we're not going to need any extra hardware accelerators or any kind of functionality in the baseband system.
Well, the encryption is optional.
Okay.
So if there's a product there that the hardware will not support encryption today, they can still implement RIST, but the only cipher that will be available for that product is basically no encryption.
Okay.
Now, I'm going to address go a little bit more technical. And you have a simple profile thing running. You open 2 ports in the firewall. Now, this is only 1. So there is going to be a minimum of network reconfiguration, or you can ride the port that you already have. But yeah, upgrading some device is going to be just a firmware upgrade.
Okay.
Yeah, that's not a problem. I think I can speak for all of us. It's a firmware upgrade, a software upgrade, and you're done. But there may be a little bit of network reconfiguration. There will certainly be some network reconfiguration if you want to switch. That's going to have, and the link's going to go down because you're going to have to upgrade both sides.
So it's a reset.
Yeah.
So it's kind of like getting a new code load on your phone.
Yeah. Well, so that's the concept of maintenance window. You do that between midnight and 1.
Right. Which time zone though? No.
Now you're asking difficult questions, Wes. I'm going to give the microphone to someone else.
Yuri, did you want to say?
So about upgrading, there is one thing that needs to be considered carefully, because RIST main profile potentially opens up the ability to send traffic to arbitrary addresses, internal addresses in the network, because it's based on a tunnel. So there might be some reconfigurations, not only of 2 ports to 1 port, but also firewall rules and so on.
Good point. Good point. Again, if there's anybody in the audience, you have any questions or anything like that, I'd be more than happy to bring them into the conversation. So let's talk a little bit about places where you've seen opportunities or successes or whatever. What's your favorite RIST application today, or your favorite ARQ application? What do you think is the most exciting thing that you've done with this technology?
Okay, I can vouch from, I have 4 installations right now with RIST. I have Cobalt encoders and decoders pushing over Open Internet and DIA, doing ARQ, works like a charm. Basically, other than encoding problems and crazy problems that crazy problems that to do with the sources with SDI. There is nothing that SDI. It's not encoding.
Oh, SDI. That stuff will never work.
Yeah, but it works. People are deploying that. People were waiting for the main profile for the encryption. That was the one thing that was halting people. That was the thing that I got from NAB, Las Vegas. People were waiting for the encryption. They said, we can't jump without the encryption. We have to go. If you are using the open internet or any type of network, we have to have the encryption. Give us the encryption, then it will be much more deployable than it is today. But some people jumped the gun. They're already using that, very happy.
What are they using it for, Adi? Is it? Can you talk about it?
We have contribution, we have some distribution, we have ProLane that they spoke about contribution, distribution application that are doing with open broadcasting coders today. There are many RFPs right now in the market calling for RIST interoperable product. I know that there was a RFP for PEG contribution.
Oh yeah. Public
using-
education and government. Yep.
Using RIST. The RIST was a requirement. It was strange to me because how do you know about RIST?
We must be doing a good job,
Yeah,
right?
must be doing, RIST was a requirement in that. I don't even know who did that project. Both me and Ciro was involved in Spain when they wanted RIST. So there are projects going right now.
Great.
One exciting RIST deployment. I'm not sure what's the scale of it, but it's a major content owner. It's HBO originating channels in the cloud using Evert's playout system and distributing it over RIST.
So are they distributing it to distribution partners?
I believe so.
Yeah, that makes sense. Okay. Ciro, you got one?
Just wanted to say that was my heart when I see an RFP and they actually say must have RIST.
That's great. That's great. I got a question from the audience. Go ahead. No,
Well, just briefly, to me, more than an existing application, I'm excited about the possibilities.
Okay.
For example, in the open source community, RIST is in VLC. Soon the main profile will be. And a great application would be watching video over Wi-Fi links based on RIST.
Mm-hmm. Live
where,
video.
Where
yeah.
the bandwidth doesn't get saturated like it does now with HLS or other protocols, we will be able to scale much better when watching videos that way.
So we're thinking stadium applications? Cool. Sounds like fun. Here you go.
Thank you. Do you have any advice for people looking to add RIST support to their products? Obviously, if 60 you have an SDK and other protocols, is it just a case of building it ourselves and getting out the spec, or is there anywhere to start with that?
Well, the spec would be the starting point so you understand exactly what's required. But after you read the spec, you're not on your own. There are several open source projects that you can go and look at entire implementations of senders and receivers. We have a GStreamer, we have a VLC media player, and we have something called UPipe. The UPipe is a full SDK open source that can be used to build application. It's actually a framework. So that alone gives you 3 separate implementations of the code. Right now they're simple profile, but soon main profile will be in all of them as well.
Yeah, I'll just add to that. Work with partners. Reach out. Once you've got something up and running, find someone who's got an implementation, reach out to us, reach out to any of the people on the stage, really, and test your implementation and test it well. Because we've been doing a bunch of interop testing before we launched it, and we did find issues and we worked through them. And so that I really recommend is really get out there and work with existing GA'd, generally available implementations of RIST to make sure you work well with them.
Yeah, I second that. I think if you reach out to any of these companies, at least mine, we are happy to schedule an interop. We do that all the time between ourselves. We schedule interops, and then we have a little set up a time, open a firewall. You send me a stream, I send you a stream. It's working. Most cases, 5 minutes is all done. 5 minutes,
Senko.
Jim.
All right.
Jim, I'm standing behind that. Most of my interrupts is 5-10 minutes. We watch the video a little bit. Am I getting packet loss? Sometimes the internet's not dropping enough packets, so we bring simulators online to drop some more and stress it. And that's it. We just watch a video a little bit. And that's something that I think it worked better than I expected, because at least in the beginning, we all did our own independent implementations, all off the spec. Now you have the open source, but we all did it off the spec. In most cases, it just worked. I literally had some sessions that was 5 minutes. Send you a stream, I send me a stream. Yeah, it's working. Let's go have a coffee.
If you plan to write it from scratch and you have an RTP flow that you already have, unicast or multicast, all you need to add is the RTCP layer and the special signaling, which is not that complex. Then you have a simple RIST profile. That's why it takes only 5 minutes, okay, to test, because it's not that complicated. To add the main profile, to add the tunnel, as I said, free. Bear me, 3 lines of code to have a simple tunnel. When you go to DTLS, you have to have your encryption, whether you want to use PSK or DTLS, then you have to do some work. But you are up and running before that. Now, if you want to select, people told you go to some of the members here. There are differences between implementation, and the RIST allows us to do so. We did not constrain everything. We allowed innovation to be there. There is innovation even in the simple RIST, and then the differentiation between a video flow solution and a ZigZag solution, and what are the features that we bring forward. So when you want to select a GA implementation, you need to check the pedigree, the experience of that group, to see what are the features that they will allow you, because there are subtle differences that will make or break a solution, and will make or break an interop. Okay?
So this is a little bit of a nerdy question, and if we want to, kind of highlight or go high on it, that's fine. But with respect to the different mechanisms for sharing the encryption keys, okay, we have pre-shared key, we have DTLS, we have certificate authorities, things like that. Where do you see the differences, and how does a user decide what kind of encryption they need? How do they choose what they're going to do with it?
So the choice is up to the user.
Of course, but how do they pick? How do you know what you're picking?
It depends on the functionality that you need. If you want to know who is on the other side, then you need to have a certificate. You can select to use just server-side certificate, both server-side and client-side certificate. You are in freedom of selecting what types of ciphers you want to use. Sometimes you just want to have encryption and ignore the certificate. Sometimes the other way around. You want to have certificate to verify that you're talking who is claiming that you're talking to, but you don't care about encryption, or you can't do encryption because of performance limitations. So you do just the authenticity without encryption. Now cipher is one of the options. If you want to do multicast, then you need to use the pre-shared key. So it's up for the application.
Anybody else? Go ahead.
Well, where you are in the world and what you think you need also is going to dictate the cipher selection, right? There's the 128-256 that we discussed before. There's some people that are happy with 128. There are some people who say absolutely not. And there's some places in the world that you can't use 256, and now you go to jail. And we don't like that.
Jail's not a good place, I've heard. Yeah.
It's also going to depend on the hardware layer. The simplest level of hardware, maybe even the inexpensive cameras might not even implement a DTLS because of the complexity of putting certificates or dealing with them. So I foresee a number of devices that will choose based on just the complexity of the setup.
So is this something that I can make into an iPhone app or a Google Play app? Do I have everything I need to make it happen?
I would say that using DTLS is no different than using TLS. It's just a matter of using UDP instead of TCP. So just like as your iPhone is able to access HTTPS websites, it has trusted root authorities that it's using built into the operating system. It's the same thing with DTLS. So you can envision an iPhone player that's able to play a RIST main profile, and you don't need to do anything except just clicking a link and it will play in a secured and encrypted way.
Cool.
obviously the ideal scenario is that eventually the built-in players in Android and iOS will have native support for RIST. Until that happens, it's still easy to create custom applications that use custom libraries that allow you to do that. Eventually, maybe we'll get to the point where it's just a link and the browser plays it.
Yep.
Don't you think that will happen with SRT? So native support in operating systems, you mean?
Do I think that will happen
Yeah.
with SRT? I don't.
SRT is being supported by Microsoft, I think. So
Right, and they're doing a very good job on marketing, and we're going to leverage that marketing to push RIST.
Okay, well, you talked about SRT, not me, but let's kick that around a little bit. Let's first of all make sure everybody understands, and maybe you've talked about this earlier today, but the difference between an open specification and open source. Okay, is that important to users, and why?
So I think in this particular case, one important aspect is that if you look at SRT in practice, Haivision is as a single company driving a lot of the efforts around SRT. So even though it's an open source project, a lot of the work, if you look at the GitHub source code, Haivision is pushing most of the code, and that might change in the future, but that's the case right now. And I think that's a big difference with RIST, where there's been a lot of vendors involved in creating the specification, right? So it's open source, but it's still very much driven by one vendor at this point in time. So I think that's a key difference for us, and that's also one of the reasons many of our customers come and say, interoperability long term, we believe that that's going to come from a protocol defined by multiple vendors. But anyone else want to add?
Yuri? Oh, go ahead, Ciro.
Another challenge or potential challenge that we've seen with SRT is that its dependency. It's not just the Haivision code. There is a dependency, a strong dependency on an open source project called UDT, which is a file transfer-based protocol from 2008, and the maintenance stopped at 2008. And SRT cannot work without a UDT layer. And unless you re-implement UDT, you are stuck with the existing implementation with bugs and memory leaks and so on that I don't believe will get into browsers unless some vendor like Microsoft will take it on and rewrite the entire thing.
Now that you brought up UDT, I'm going to repeat what Kieran said in an earlier talk, the technical that. I didn't think about it that way, but UDT, the basis for SRT was a file transfer. And the requirements to transfer a file are different than the requirements to transfer video. File, you got to get all the bytes in there reliably, no matter how long it takes. Video, there's a deadline, and after that deadline, that packet's no longer needed. Yeah, it glitched already. I don't care anymore. It glitched. So it started from the wrong basis. Okay, and then you can come and kill me later. But it started from the wrong basis. Well, and that's why you can hear from multiple people, even in the documentation, the performance of RIST is much better. The protection is much better. SRT tops out at 8-10%. That's from their docs. All of us here have run RIST over 30 or 50% packet loss is still working.
There's also the concept that SRT wants to control the source code and give everybody a library to use in all the platforms. There's one source base, and everybody needs to use that library to implement the protocol. That's a very different concept that it's not what's typically used for a standard. A standard has many implementations and sometimes some helper libraries, not a single DNL that's expected or library that's expected to use across all the operating system and platforms controlled by just one repository.
So as you can imagine, I've been in a lot of meetings where that SRT has come up over the last, I guess, nearly a year now. A lot of people ask about it. In my opinion, has remained constant throughout since we launched. Our view is we've done testing, and our view is that it is an option. it's possibly suitable for events, but when it comes to 24/7, the accuracy is just not there. It's just not got the quality that we see in RIST. And so whenever it comes up, our position is that we think RIST is the future. We think it's a standard that we can all stand behind, that we can all implement, and not just an open source project that is sort of masking as a standard. I think those two things do get confused quite often in our customers' minds, definitely. I was surprised, if I'm honest, about the Azure coming from another, obviously, competitive cloud vendor. I was quite surprised about Microsoft's very public endorsement of SRT, as I think probably most of us were.
Speaking of Microsoft's endorsement, it's a strong endorsement, but it's mostly a marketing endorsement. Microsoft have their Microsoft Media Services, kind of equivalent to AWS Media Services, that supports today two protocols, RTMP and smooth streaming. Both are poor choices, but this is what Microsoft chose. They dropped support for RTP last year, and SRT is not in Microsoft Media Services. It is marketed by Microsoft and Haivision, but it's not supported natively in the platform.
Okay, I see a couple folks in the audience. There we go.
I didn't have a question, just a comment on your question, actually, in terms of the value of an open specification. And from a vendor standpoint, going back to a point I made in my presentation earlier, when you go into high bandwidth workflows, we truly see need for having to do implementations in FPGA. And then we need an open specification. We can't rely on a public open source component.
Sure, that makes a lot of sense. Is somebody else back here? Okay. So let's talk about... go ahead.
If I can.
Yeah.
First of all, I have to say VideoFlow implemented SRT. We're going to announce SRT, joining the SRT Alliance. And I have to share my experience with SRT. It's a very good solution. It's very easy to deploy. You take a library and it works. But when you go to test it in the field and you run it through the test that we will normally run a VideoFlow or a RIST suite of tests, it will fail. Because it's very good on a point-to-point, on a very good SLA type of links. But when you deploy that on for instance, we tested from AWS to a ADSL receiver, it failed after 5 minutes and oversaturated the link. We had to go and tweak the configuration, and that was experts doing that to make it stable, while with the RIST it worked immediately. With the SRT, you have to be a super experienced person to know what to do in order to make it work. So on a very short links, even in AWS between EC2 to EC2, it will work. But for the long duration on a challenging networks, it will eventually will fail. Another shortcoming that SRT has today, that maybe they will fix that, is there is no authentication. Unlike DTLS, that you have certificates, there is an encryption layer in SRT, there is no authentication. How will AWS know that I'm allowed to stream into AWS? Simply, am I allowed to stream into their facility and I'm allowed to receive their content? Something like that is not there. Now, we do also see that Haivision is doing a lot of development. They are going to add bonding in the near future. They're going to add fault error correction, which is missing right now, into the implementation. Some people say that even RTP is finally going to be fully supported. Today you can support it as a native UDP. So they are making efforts, but once again, it's one maintainer. We don't see the whole community joining and adding more and more capabilities. And that is a big risk. If that maintainer will stop, what are you going to do with your code? It's a question that you have to ask yourself day after day. With RIST, you maybe decided to go with DVO, but then DVO went under. So just as an example, you have ZigZee, you have NetInsight, sorry, NetInsight. They were bought. Sorry.
This is what our meetings are like, guys.
Meaning that you have continuity. You have other vendors, you have an open specification, you can implement that yourself, you can buy, you can continue. You are not putting your future on only one source.
Are you the troublemaker in the group?
Yes.
We have multiple troublemakers.
I have to
trust me,
protect my
trust me,
patent.
multiple.
This is why we need you to wear.
Well, I have played referee a few times, but you know, the neat thing is we're all rowing together. So on a more serious note, first of all, if there's any questions, let me know. Okay.
So you guys spoke about Zixi, you spoke about SRT, and you spoke about RIST. There's yet another beast, Sandstrom. Can you say something about that? Like,
Okay, I can. John here is from ex-Aspera, now Zixi, so you can probably talk more about it. But from my perspective is, unlike UDT, which was a UDP-based file transfer protocol that performed not so well, Aspera had a UDP-based file transfer protocol that performed excellently. And they built a live streaming protocol on top of that. Again, with all the limitations of no forward error correction, no backwards compatibility, and so on, but at least it's based on sound, at least theoretically sound, stochastic control theory mechanisms that allow you to saturate a link in a fair way without causing congestion and so on. So it is potentially an attractive product. Unfortunately, IBM kind of buried it, and I'm not sure what's the future of Sandstrom, especially now with the era of RIST. There is, and Aspera are not participating in the RIST group, so it is yet another solution that we are not sure how it's going to be supported in the future by IBM.
Not specifically about Sandstrom, but the cool thing about RIST, again, it's not the ARQ. ARQ, we all had ARQ products. All of our ARQ products work really well. It's just they didn't interoperate. That's the thing here, is the interoperation. Okay, we're not super smart that we came up with something that's, well, he is, right?
I think there's a few of you. You would be included in that too, Ciro.
Oh, thank you.
So let's talk about one thing that I think has got to be, you know, top of mind for all users, anybody who's buying technology. What are the license terms for RIST? What do I have to pay anybody? Does anybody own any intellectual property on RIST?
Pay me.
Yeah, pay you for what?
For nothing. It's free. Okay.
Okay, legally, VideoFlow donated, basically issued an IPR with RunZ on one of its patents. Theoretically or practically, vendors should register themselves and get a free license to use the patent under the terms of the IPR. We're not going to pursue you guys. We're not going. It's free of charge. All you need to, if something will come, you just say, "Oh, I acknowledge VideoFlow." That's it. But we were not going to charge you any money for that.
So RANZ, let's just define that for the audience. So it's zero cost, and it's available to all takers.
All
correct?
you need to do is just to acknowledge that you're using a VideoFlow patent for RIST. That's it.
Okay.
We did not pursue anybody yet, and it's for free. That even if we pursue you, all you need to say, okay.
Ciro, did you want to add to that?
Yeah. So, in addition to taking what Adi said is in place, but so specification is free. You can freely download it from the Video Services Forum website, and implementations are free. There's public domain code, and there is no royalties you need to pay. So you can use. Now, of course, you want to buy product from us, that costs, right?
Well, I mean people have to pay for products, and I don't think that's an issue. But there is no lurking thing like we had with MPEG-4 LA or, per stream charges or the patent pool or all that. None of that stuff applies to RIST.
Right. And I also wanted to add that the specification left room for each vendor to apply their magic sauce, especially on the buffering mechanisms and the anti-jitter and the congestion control. All that stuff, each of us can still leave our own magic sauce in place and interact with each other. So it's up to the consumer if they're going to implement RIST themselves or buy a solution to compare vendors and see how they implemented those three parameters come to mind.
So let's just again be clear for the audience here. For example, MPEG specifies an interface between an encoder and a decoder, but there are massive differences in terms of price and capabilities of encoders. They range from $20 boxes to $20,000 to $50,000 boxes. So there's a wide range that all meet the same interop spec. So you can take the output of encoder A and feed it into encoder B. That's kind of what we've achieved with RIST. In other words, yes, there might be somebody who does a better job of handling buffers on, very large bandwidth streams, things like that. But they still will be able to interoperate with the other devices that are out there. So that's the key message here. This is a standard. It's not a single, source implementation. It is truly something that is going to have a wide range of implementers and developers working on it. We've already got a pretty good group right now, but I see that getting bigger.
Yeah, just to add, I think RIST would be dead on arrival if we tried to monetize it. I don't think that's the play here at all. The beauty of it is that it brings people like us together to work together in new and exciting ways, and hopefully that list of vendors and ISVs working in the space will grow exponentially, I hope, so that we can all find cool new stuff and cool new ways to work with our customers.
Yeah, I want to stress on the innovation point. RIST defines a way to interoperate, but doesn't define in detail the algorithm. So it's just like Wes said, you can have two MPEG encoders. They are both running at the same bit rate. They are both generating a compliance stream. One looks better than the other. Same thing with RIST.
Yeah, I mean, it depends on your application. Noisy video, whatever, and for encoders. But for RIST, you're different types of networks will respond differently to different implementations. That's for sure. So let's wrap this up. I guess the question I'd like to sort of close with is, what is it that where do you see RIST in, let's say, 2 or 3 years? Staying aside from, I don't want to get into like lists of new features and things that we can have. Where do you see it going in the market? How do you see it impacting our industry? What do you see being transformational about RIST that we haven't seen before?
Well, the main drive in RIST was multi-vendor. So I think the use of the internet as a contribution link is being held back by the fact that A doesn't talk to B. When A starts talking to B, that's going to become more prevalent. And eventually what I'd like to see is that flowing into people's homes as a transport mechanism for life. If anybody should watch live, right?
Well, it's live. It's fun once in a while. Or depressing, depends on like election results or something.
Yeah, let's not get into that, shall we? It's probably not great. I think transformative is the right word. I think we're going to see an explosion of innovation and interoperability across vendors. I think we're going to see production turn itself on its head, in a way that we've never imagined. I think we're going to see vendors finding, bringing to market partnerships and solutions based on pockets of innovation that ultimately are going to completely change the way we think about not just sending content from point A to point B, but the entire supply chain.
I personally think RIST is going to be the final nail in the RTMP coffin. So.
That would be Alex, did you?
No, you already touched upon it. I think, and I mentioned that briefly before, but I think the whole area of like professional media workflows over the internet has been growing a lot in the past 5-10 years, right? But I think this is kind of the thing that's going to unlock a more explosive growth in that space. So internet for professional media transport is really, really taking off with RIST.
I agree 100% with the professional media. I want to say what RIST will not do. So RIST will not replace HTTP, and RIST will not replace other protocols that have their use cases. For example, WebRTC, which is unique use cases, adaptive-based streaming like HLS, Dash, and so on. So it has its room, but it will not take over any video over the internet.
I have to state that RIST does have the potential to replace or actually augment low delay, low latency, live delivery to the mobile area. With the use of adaptivity and techniques, you can provide a low latency delivery that cannot be provided today by way of CMAF or even WebRTC. We can change WebRTC to be like RIST or vice versa to deliver that content. And that will be the most exciting thing. If we can converge WebRTC and RIST into one protocol that will go reach the mobile 5G, then that will be a huge step forward into the industry, new innovation, new business opportunities, video everywhere. That will be the end of it.
Yeah, and of course that's an exciting thought, right? But I think where RIST is strong and what I believe we're going to see in the next couple of years, it's back to my previous statement about professional media workflows. I mean, contribution links, primary distribution links, affiliate interconnect, and affiliate contribution. When you're talking massive distribution to 100,000 or millions of endpoints, it's not designed to scale for that, right? So I think we might disagree, but that's my take on that anyway.
There's a first time for everything, right?
Yes. First time we disagreed. Good.
Yeah.
So as AWS, we have solutions across that. And I do agree to some extent that the future of streaming, it looks to me that it probably isn't about segmented workflows, at least to get down to latencies that chunk CMAF can't get to. So I do agree, I think there is a future for streaming technologies. Whether or not that's RIST, I think that's part of the exciting part about being part of this standard, is that we'll see where it goes and we'll see where it takes us. And really, it's not just up to us, it's up to everyone else in this room to help us figure that out, I think.
Okay. Anybody else from the audience? All right, that's good. I think we ended on a pretty high note. So Alex, the beverages are due?
Yes, they should be arriving any day now. No,
Any day.
Any day. Oh, no.
No, but I think they're ordered for 1:15, so yes.
Okay.
A few minutes and there should be,
Yeah, we'll neaten up a little bit, and please, feel free to talk to the experts. I mean, you won't find another group of people on the planet that know more about RIST than the ones that you see sitting here. So if you have any questions, if there's something you didn't want to share with everybody else, by all means, talk with these folks. And hang out for 15 minutes, and we have beer and munchies, I guess, right? All right. Thank you, everybody.